Okay, this lecture is over Chapter 5 of your textbook, which is titled Attack Types. So we're going to talk about the different types of attacks that you might experience or might be investigating. So we'll talk about those attack types. We'll talk about how to recognize the different attacks. We'll talk about how attackers try to evade detection so that you don't know they've compromised your system and or are causing problems. So one of the first types of attack, and a very common attack, is referred to as a denial of service attack, abbreviated DOS. And basically what a denial of service attack is trying to overload a machine, a website, a network with excessive traffic or request from a single source, trying to make that site become unavailable and or crash so that it is not available for legitimate users to do their legitimate work. A variation on this is called a distributed denial of service attack, abbreviated DDoS, and it is the same thing and serves the same purpose as a DOS attack, but the attack comes from multiple sources. So you have a collection of devices, maybe tens, maybe hundreds, maybe thousands, trying to attack a single site, machine, or service. One example that your textbook talks about is a SYN flood. And to understand that, you need to recall from your previous courses the TCP three-way handshake. And basically, this is what that looks like. So you have two devices on the network or on the internet, and time is going downwards. So the first thing is when device 1 would like to create a TCP connection with device 2, it sends a SYN request, and it has a sequence number in it. When device 2 sees that, it replies back and sends back a SYN ACK. So it has the SYN flag set with whatever sequence number it's using to talk back. And then it sends an acknowledgement, and the acknowledgement is the sequence number that device 1 sent incremented by 1, so that it knows which packet is being acknowledged. And then when device 1 gets that, if it's happy, it sends back an acknowledgement. It takes whatever the SYN sequence was from device 2 and adds 1 to it, so that device 2 knows which packet you're acking. So that is the three-way handshake. So in the case of a SYN flood, the malicious device sends a send with a sequence number when it didn't really, just sends it. And then the device being attacked returns the SYN ACK, and then device 1 does not do anything. So it leaves the connection half open. And in the case of a SYN flood, you do that over and over and over again until you tie up all the slots in the device being attacked, and that will cause device 2 to no longer be able to accept any new legitimate connections. Now, another type of denial of service attack is something called malformed packets. And basically what that is forming packets that violate specifications and create non-conforming, invalid packets. One of the first attacks of this type many years ago was called the teardrop attack. And basically there was a bug in the TCP drivers of machines that if you sent a packet that was too large, that is larger than what the maximum packet size could be, it could overflow a buffer and ultimately crash the computer. So that's teardrop attack. So from your textbook, figure 5-3, they show you another malformed packet that this time it's not a TCP packet, it is an HTTP request. So a normal HTTP request should just be get/HTTP/1.1. And what they've done is they just repeated that over and over again, trying to cause the server or the web server software running on the server to get confused and crash. There's also something called UDP floods. UDP in itself should be reviewed. If you have a good understanding of UDP, then you may possibly find this joke funny. That is, I have a really good UDP joke for you, but I don't know if you'll get it. So in the case of a UDP flood, we send many UDP packets very, very quickly with no delay. And figure 5-4 of your textbook shows a capture. Notice that the source is one machine, a destination is another machine, and notice it's a slew of UDP packets. And then look at the time, the offset from the first packet. These are in the hundredth of a thousandth of a second. So these packets are being sent very, very, very quickly. And what you're trying to do is, again, crash the protocol stack, possibly crash the machine. Another thing your book talks about is amplification attacks. Basically, what this is doing is getting other machines to help you with an attack. One of the first attacks that was an application attack is called a Smurf attack. Now, depending on the age, the Smurf cartoon may or may not have been a thing. But when my older kids were growing up, they watched Smurfs all the time. And there are a lot of Smurfs. And new Smurfs appear magically delivered by storks during a blue moon, originating from an unknown place. So basically, they're trying to inundate a service with a bunch of, in this case, packets. So it was called a Smurf attack. So one example is pinging the broadcast address, which I show you on the next slide. So typically when you do a ping, you're pinging an individual host. But if you ping, in this case 192.168.0.255, that is a broadcast that's going to send an ICMP request to the broadcast address, and that means every machine on the local network that is powered on will get that ping and they will respond to it. So I did this in my house and noticed that instead of getting ping responses back from a single host, I'm getting them from lots of different hosts in my house. So these may be my TV, my printer, my daughter's laptop, my wife's laptop, the router, and any other devices that we have that are on our Wi-Fi network. So this is just trying to create a lot of traffic, again, to deny service. A distributed attack, we've already talked about it a little bit. This is using multiple machines when performing an attack. A lot of times these attacks are coordinated by messages within a botnet or within IRC, which is inter-relay chat. Inter-relay chat was one of the first chat direct messaging type services on the internet and has been around for many decades. But anyway, you compromise machines and you have bots setting out there, or software that is periodically checking to see what if it's supposed to be doing. And for example, in this IRC channel, you can basically say, don't do anything, don't do anything, don't do anything, and then all of a sudden do something like, okay, I'm mad at FedEx, let's attack FedEx.com. And then all these, like I said, tens, hundreds, thousands of machines will start attacking whatever device. And then at some point in the future, you can maybe say, okay, stop attacking and hang out until I have something else I want you to attack. So that's a distributed attack and some discussion of what a botnet is if you've never heard that term before. Another denial service is referred to as backscatter, and that is network reply traffic that comes back to you even though you didn't start the conversation. And again, these are coordinated by messages within a botnet. The next type of attack we're going to talk about is referred to as vulnerability attacks. And these are exploiting a bug or vulnerability with an operating system or program or application. So there may be a bug in a program, and before people fix that bug, they may be able to compromise your machine or cause it to crash or something else that is bad. Next thing your book talks about is insider threats. And insider threats generally mean you have a person, whether it be an employee or a contractor, for a company that does something, quote, bad. This could be stealing data, could be compromised, etc. There are reasons that this might happen. There might be a disgruntled employee who is mad and wants to cause problems for the company. They may be wanting money. They might want to steal trade secrets, things like that. The other thing this chapter talks about is evasion, which is trying to hide an attack or possibly the source of attack. And there are different ways to do this. One of the ways that is very common is base 64 encoding of your malicious code. So base 64 was created so that you could send images, programs, binary data through email. So it converts all the bytes of a file into printable characters so that you can send it and then at the other end decode it and get the original back. So if you had a malicious program that somebody might have a quote signature for and might go searching for, if you base 64 encode it, it's just going to look like garbage to whatever tool is scanning the code or the email or however you're distributing your malicious software. Another thing it might do is it might send small chunks of the code and then reconstruct it. They might use bogus MAC and or IP addresses to send data. Was trying to think. Seemed like there was something I wanted to say about this. They might use VPNs, I guess is what I was going to say, virtual private networks, which encrypt information and make it look like you're coming from another location, often another country. So I don't know if the book mentions that or not, but that is definitely something that would fall in this category. The next thing they talk about is application attacks. And instead of attacking a machine or the network or even the operating system of a computer, it is attacking or trying to do something bad and or gain entry through an application. So this might be a bug within an application. There are attacks that use HTTP to do that. There are also something called SQL injections, where you try to put malicious SQL code in a web form. This is a very popular cartoon that discusses that. Basically, the person gets a call from school and says, your son's school is having some computer problems. And it's like, oh, did he break something? And they say, did you really name your son Robert, parentheses, semicolon, drop tables students, semicolon? So what somebody did is they typed that in a box, trying to have a valid name, but seeing if it will also execute the drop table students, which would wipe out the table called students if one exists. And the person replies back and says, oh yes, little Bobby Tables, we call him. And it says, well, we've lost all of our student records and we're not happy about it. And then the person says, well, I hope you learn to sanitize your database inputs. So if somebody had a web form that asked for a last name, then there should be some validation or mechanism to remove or alter or not accept something that has, in this case, for example, malicious SQL code. So that finishes up the chapter on attack types.